Okay. November 2018, paper 3, variant 1. Question 1. Describe the movement of the student as shown in figure 1.1. The motion of the student, initially he was moving at a constant speed. Of what? Constant speed of 4 meters per second. For how long? For 80 seconds. And then what happens? And then he starts to decelerate. And then he starts to, at this point, he starts to decelerate. But initially, we need to say that he moved at a constant speed. Constant speed, yes. At constant speed of 4 meters per second. And then, okay, he decelerates. Okay, until he stops. Can I say constant speed of 4 meters per second for 80 seconds? Yes, you can say that for 80 seconds. Okay, for 80 seconds, and then he stops. Okay, calculate the distance traveled by the student between 80 and 100 seconds. Between 80 and 100 seconds, what happened? Between 80 and 100 seconds, this is a area under the graph. Distance in a speed time graph, you need to find the area under the graph, and the area of this shape is a triangle. So area under the graph, which is half times base times height. Yeah, half times base is from 80 to 100. Base is from 80 to 100, which is 20, times the height, which was 4. Half times base times height, this is 40. So 40 meters. Excellent. An athlete runs 630 meters in 130 seconds on a flat section of road, and then 254 meters in 40 seconds downhill. Calculate the average speed. Average speed equals total distance. Average speed equals what? Total distance over total time. Over total time. Total distance is 630 meters plus 254 meters. 630 plus 254 meters over. Total time is 130 plus 40 seconds. So total distance over total time, this would give me an average speed of 5.2 meters per second. 5.2 meters per second. Easy. Well, I have a raft floating on water. State the name given to the force shown in 2.1. Yes, downward force is weight. Okay, downward force is weight. Um, what we have B area under the average speed 5.2. Average speed was 5.2. Yeah. State the name given. This was weight. Calculate the mass of the raft. How can I find the mass of the raft? If you have the weight, then you can find the mass. How can you find the mass? Mass equals weight over g. You know the initial equation. Okay, the original equation was weight equals mg. So mass equals weight over g, which is 20,000 divided by 9.8. 20,000 divided by 9.8 is around 2,040 kilograms, correct, if I'm not mistaken. Okay, 20,040 kilograms. A sail is added to the raft as shown, and then we have two forces acting on the raft. Can I find the resultant horizontal force? How can I find the resultant horizontal force? 1,200 minus 800. Which is 400 newtons. In which direction? In which direction? To the right. Or forward. You can say either. To the right or forward. Forward or to the right. Okay. It's in the direction of the larger force. Direction of the larger force. Okay. Um AII, weight equals mg. Weight equals mg. So mass equals weight over g. You just divide the weight by g. Divide the weight by G. So weight divided by G, 2000 divided by 9.8 is 2040, if I'm not mistaken. 20,000 divided by 9.8. Yes, 2040. Okay, good. Yeah, moving on to the next question. 400. ماشي. Yes, moment equals force times perpendicular distance. Moment equals moment of the counterweight Yeah, the counterweight was 80,000 newtons, and the distance to the pivot was 5 meters. So 80,000 times 5 is 80,000 times 5 is 400,000. The unit of the moment. The unit of the moment was newtons وهنا dot meters. So newtons dot meters. Yeah. Moment equals force times perpendicular distance. Wait, can I find the weight? Can I find the weight of the load W? Can I find the weight of the load W? Yes, I can find the weight. Clockwise moment equals anti-clockwise moment. 80,000 times 5, the moment we found was the clockwise moment. This was a clockwise moment. Can I find the anti-clockwise moment? So I have to say that the anti-clockwise moment is equal to the clockwise moment, first of all, because it's balanced. It is balanced. Anti-clockwise moment equals clockwise moment. Clockwise moment is 400,000, and the anti-clockwise moment is the force times the distance to the pivot. What was the distance to the pivot? It was 8 meters. So force times 8 meters. Yes, exactly. Thank you. It is 50,000. That is correct. Divided by 8 is 50,000 newtons. Okay. Hmm. Next question. We have box A and box C. In box A, draw the arrangement of particles in a solid. In a solid, they would be in a lattice arrangement. They would all be arranged, okay, fixed in place. Okay, yes, this is a solid, some solid molecules. What about the gas molecules? They are fast and random, very far apart. Box C. Write down the term for each change. For each change. From solid to liquid, melting. From gas to liquid, this is condensation. Yeah, condensation. A wet beaker is in a warm room. After several hours, the beaker is dry. State and explain what happens to water. Hmm. What happens? Evaporation. صح? Evaporation. What happens during the evaporation? The most energetic molecules escape from the surface, leaving behind the least energetic molecules. Huh? Or you can just say that the most energetic molecules escape from where? From the surface. That's it. That's all we need. This is only a 3 marker. You need to state, first of all, the name of the process, which is the evaporation. Yeah, evaporation. And then you can just say that the most energetic molecules escape from the surface. From the surface. Good. Yep. Moving on to the next question. A tidal barrage, a dam. Okay. With the tide coming in and the tide going out. The water behind the barrage is a store of energy. Okay, it stores one type of energy. What is this type of energy stored in the water behind the dam? The type of energy as the level of the water rises, it becomes stored in a type of energy called gravitational potential energy. Gravitational potential energy. Gravitational potential energy. No, not kinetic. It's not moving yet. It's not moving yet. It's now stored in a gravitational potential energy. Okay, this is the form of energy stored in it. Explain how the tidal barrage produces electricity. how is electricity produced? We have a turbine, we have a generator. As the water moves, okay, as the water moves, it changes from what type of energy to what type of energy. It changes from gravitational potential energy to kinetic energy. Let's write it down. As water moves, it changes from gravitational potential energy to kinetic energy. Thus, it starts to rotate the turbine, rotating the turbine, which is attached to the generator. The turbine has to be attached to a generator. Generator wouldn't produce any electricity. The generator wouldn't produce any electricity unless it rotates due to a turbine. يبقى rotating the turbine, hmm, which then rotates the generator, producing electricity. Producing electricity or electrical energy or whatever. Okay, 3 marks. Next question. State the term that describes the materials that are poor conductors. Poor conductors of energy. Insulators. Poor conductors. So draw a ring around each material that is a good conductor. Good conductors. We have aluminum and we have copper. Aluminum and copper. Hmm. A student has 2 rods made of different materials. The rod are the same size. Describe an experiment to identify which material is the better conductor of thermal energy. Which material is the better conductor? How can I find the better conductor? Dirty. We have 2 materials. For example, we had aluminum and copper. I don't know which of them is a better conductor of thermal energy. We need to attach small pins. Okay, we need to attach small pins on each of these conductors wax, using wax, and then we need to use some heat source. For example, we have these 2 conductors. Let me draw it for you to understand. Okay, so this is the rod, and this is the other rod. Okay, they are both the same length, the same thickness, everything, and then we have the pins attached to the rods. You know, these pins attached to these rods. Again, they are the same pins attached how they are attached using some wax. And then you have a heat source, a candle, a Bunsen burner, whatever heater. And this heater will start to heat up both rods. The better conductor, okay, the rod which is the better conductor will hmm, will have its pin, the pin attached to it. The pin will fall first. Why? Because it's a better conductor of thermal energy. It will transfer the energy faster than the other rod. It will transfer the energy faster than that. That's it. Okay, so we have 2 rods. Okay, attach 2 pins. Okay, attach pins using wax to the end of each rod. Okay, we have the rods attached to them, the pins, ماشي, and then use a heat source to heat up both rods. Okay, both rods to heat up both rods. The rod of the pin which falls first, the pin which falls first was attached to the better conductor. That's it. Okay? Yeah, let's go on. Okay. Figure 7.1 shows the electromagnetic spectrum. One type of radiation is not labeled. What is this type of radiation? Radio, micro. The only one missing is the ultraviolet. The ultraviolet radiation. Okay, the ultraviolet radiation. Um, the arrow, I'm sorry, the arrow indicates a property that is increasing. Yes, the wavelength is increasing. Thank you. The wavelength is increasing as you're moving in this direction. Compare the speeds of the radio waves and the visible light. The speeds of the radio waves and the visible light, they are equal. Okay, they are the same speeds. They both have the same speeds, which is 3 times 10 to the power of 8. Describe how X-rays are used for security in airports. X-rays in airports. We use them for the security checks. How do we use them? Okay, how do we use them? Um, Quite simply, we can say that they are used to check bags or to check people or to check whatever. Okay, for any hidden objects, to find objects inside hidden bags. Yes, that's correct. Okay, to find objects that are hidden inside bags. That's it. Yes, to find, okay, objects that are hidden inside bags. Explain the properties of X-rays that make them useful in airport security. X-rays. Why are they useful? Oh, how how are they used? Um, quite simply, X-rays can pass through human flesh and bone. X-rays can penetrate human flesh and bone, but they cannot. Okay, they cannot pass through metals, or pass through metals or pass through different objects with different speeds. Okay, they are absorbed. Okay, the X-rays are absorbed by denser materials, and that's why the metals appear. Okay, on the X-ray scans, they are absorbed. Okay, they are absorbed by denser materials, and that's why they appear on the X-ray scans. Hmm. The objects appear. Okay, the denser objects appear on the X-ray scans. X-ray scans. Okay. Some of the properties of X-rays. I have a tuning fork and a wooden block. The tuning fork is hit against the wooden block and then makes a sound. Describe how the tuning fork produces this sound. By vibrating. Yes, by vibrating. That's it. It vibrates. Okay. The tuning fork produces a sound with a frequency of 659 Hz. State whether a healthy human ear can hear this frequency. Explain your answer. Can he hear it? Yes. Why? Because as humans, yes, because humans can hear frequencies from 20 Hertz to 20,000 Hertz. Okay? No, this is not an echo. This is not an echo. Okay? Humans can hear from 20 Hertz to 20,000 Hertz. Okay? يلا. Hmm. يلا. A second tuning fork produces a different sound. Compared with the sound represented in 8.2, this sound is quieter and has half the frequency. Quieter and has half the frequency. Quieter means, okay, quieter means that it has a smaller amplitude. صح? Quieter means that it has a smaller amplitude. Half the frequency means that it has um, a frequency which is much less. Okay, how can I draw half the frequency? Half the frequency would be something like this. Okay, that's it. Okay, so this has a shorter amplitude and a longer wavelength, meaning that it has a less frequency. Its frequency is has decreased. Okay. Hmm. Student experiments with electrical charge. The student uses a dry cloth to rub a plastic rod. The rod becomes positively charged. The rod becomes a positively charged. Explain how the friction between the rod and the cloth causes the rod to become positively charged. How does the rod become positively charged? How can a rod become? It loses, yes, electrons. To where? It loses electrons to the cloth. Yes, that's it. 2 marks. Loses electrons to the cloth. ماشي. Hmm. Student suspends the balloon from an insulating thread. The balloon has an electric charge. Explain how the student can use a positively charged rod to determine the charge on the balloon. How can he use a positively charged rod to determine the charge on the balloon? Get the I'll put the rod closer to the balloon. Put the rod close to the balloon. If they repel, if the balloon is repelled, if it repels, yeah, repels, then the balloon is positive. If it attracts, okay, if it attracts, then it's negative. Balloon is negative. Balloon is negative. That's it. Yes, that's it. That's all you need to say. Okay. Hmm. The student does an experiment to determine the resistance of a fixed resistor, or student draws an incomplete diagram. Draw the missing symbol circuits. He wants to determine the resistance, and we all know that the resistance R equals V over I. Resistance R equals V over I. So we need to find the voltage and the current. First of all, the voltage is found using the voltmeter. Is used using the voltmeter. So we need to draw the voltmeter parallel to the resistor. Parallel to the resistor. This is the voltmeter. What about the ammeter, huh? It is in series with the whole circuit. In series with the whole circuit. Voltmeter and ammeter. Yeah. Describe how the student could use the circuit to determine a reliable value for the resistance R. Reliable value for the resistance R. How can I find a reliable value? I need to repeat. I need to repeat. This is worth what? 4 marks? Yeah, 4 marks. How can we repeat? How should I repeat? That's the question. Should I repeat? First of all, I need to close the switch, and then I need to change the resistance of the variable resistor. For each time I change the resistance of the variable resistor, I need to calculate the resistance again. I need to calculate the resistance of the resistor R equals V over I. Okay. Um, he wants to find the resistance of the resistor R, resistance of the fixed resistor R. He wants to find the resistance of the fixed resistor R, and that's what he said. Okay, he wants to determine the resistance of a fixed resistor R. To make sure, okay, now we found V over R. So we found R equals V over I. For example, the resistance was 20 ohms. So how do you make sure that it's 20 ohms? You need to repeat. Do I repeat with the same numbers? No. You need to repeat with different numbers. This is more of a paper six question. It's more of a paper six question that you repeat, yes, but using different values of the voltage and different values of the current. So first of all, you close the switch. Okay, close the switch, and then change the resistance of the variable resistor, of the variable hmm, resistor. Then, for each resistance changed, for each resistance changed, measure or take the reading of the current and take the reading of the voltage from the ammeter and the voltmeter. Okay, take the new readings of the voltage V, of the voltage V from the voltmeter, from the voltmeter, and current I from the ammeter, from the ammeter. حلو يبقى دلوقتي what did we do? We changed the resistance. When the resistance changes, the current will change and the voltage will change, and we need to take these readings, okay, and then measure out, then calculate the new resistance R equals V over R. Okay, calculate the new resistance, calculate resistance R equals V over I, and then repeat and take average. Oh, again. Repeat and take average. That's it. You need to repeat. How should I repeat? Using different values of the variable resistor. The variable resistor will cause the voltage of the potential difference of the resistor to change. It will cause the current in the in the wire to change, and therefore you will keep on repeating. Okay, you will keep on repeating, and yes, each time you will end up with the same value of this resistor. Why? Because the voltage will decrease and the current will decrease, or the voltage will increase and then the current will increase, and therefore you have the same value of R resistance. Okay, yeah. Close the switch, change the resistance of the variable resistor, take the new readings of the voltage from the voltmeter and the current from the ammeter. Um, Calculate the resistance R equals V over R. Repeat and take average. Repeat and take average. Yeah, moving on to the next question. Figure 10.2 shows a 20 ohm resistor connected to a power supply. Another one, okay, another resistor is connected in series with the first resistor. State and explain how this affects the current in the circuit. When you add another resistor in series, when you add another resistor in series, what happens to the total resistance? The total resistance will increase. Okay, total resistance will increase. I'm adding another resistor in series, so this is another 20 ohm resistor. So what happens to the total resistance? The total resistance increases. Resistance increases, and it becomes equal. Resistance is now equal to what? Resistance is now equal to 40 ohms. Total resistance is now equal to 40 ohms. What happens to the total current? The total current decreases. The current decreases. Why? Oh, what's the new value of the current? The new value of the current is 0.2. Okay, the new value of the current is 0.2 amperes. Why? Because the resistance was doubled, and therefore the current will be halved. They are inversely proportional. Inversely proportional. Okay, as you increase the resistance, the current decreases. The resistance was doubled and the current was halved. I do not care about the voltage. Okay, you do not care about the voltage in this question. Hmm. Yeah. A student has a model electric railway. The model uses a step-down transformer. The input voltage is 230 volts. The transformer has 1710 turns on the input coil, 90 turns on the output coil. Input coil, so this is NS. Output coil, so this is NP. I'm sorry, NP and NS. Okay, this is NP, the primary number of coils. This is NS, the secondary number of coils. This is VP, the primary voltage. So you need the output voltage, which is VS. So VP over VS equals NP over NS. 230 over Vs equals 1710 over 90. Cross multiplication 230 times 90 over 1710. Cross multiplication, this would be around 12 volts. 12 volts. Okay, yeah. Moving on to question B. A step-up transformer is used to increase the voltage. Step-up transformers and step-down transformers have different coil arrangements. انت you said the step-up primary is less, step-down secondary is less. Yes, okay. For the coil arrangements, it's okay. You can write either. You can write either or you can write both. It doesn't really matter. Let's write down, for example, for the primary, for the step-up voltage. يلا. Step up voltage, step up transformer. I'm sorry. In the primary coil, okay, the primary coil has less turns than the secondary. What about the step down transformer? Let's step down transformer. The primary coil has more, صح? Has more turns than the secondary. That's it. That's all you need to say for this question. Explain the advantage of transmitting electricity at high voltages. When you increase the voltage, step up transformer. When you increase the voltage, what happens to the current? The current decreases. The current decreases. Why is this an advantage? Why is this an advantage? Because less energy is wasted. Ah, less energy is wasted. You less power is wasted, less heating effect. Okay, less heating effect, and can use thinner wires. Can use thinner wires. More efficient. No, do not write down more efficient. Don't write down more efficient. Current decreases, less energy is wasted, less heating effect, and can use thinner wires. Okay. Hmm. Moving on to the last question. State the number of protons. Number of protons is 6. Number of electrons, 6. Number of neutrons, 14 minus 6 is 8. 6, 6, and 8. Carbon 14 is an isotope of carbon. Um, of Okay, of carbon, carbon 12 is another isotope of carbon. Compare the nucleus. How can I find the difference? Okay, what is the difference basically? What is the difference? Similarities and differences between them. Similarities, they both have the same number of protons. Same number of protons. Okay. More, you're saying more neutrons. Okay. Yeah, let's let's write them down. Yeah, but same. They both have the same. Yeah, same protons, same number of protons, which is six. Okay, different number of neutrons. Okay, different number of neutrons, in which الcarbon 14 has carbon 14 has 8 neutrons. Carbon 12 has 6 neutrons. Okay? You need to state the difference. Okay? Same number of protons, same, you can say it's same charge. Okay? Different mass number, different nucleon number. Okay? Let me write down here different mass number as well. Different mass number. Okay? يلا يا شباب. Scientists, يلا, scientists use carbon 14 to estimate the age of wood that is very old. A very old sample of wood contains 1 times 10 to the power of 18. When a new sample, okay, it contained 8 times 10 to the power of 8. If you have a new sample, it contains 8 times 10 to the power of 8. The half-life of carbon is 5,700 years. Half-life of carbon is 5,700 years. Estimate the age of the wood. If you have a new sample, it has 8 times 10 to the power of 8. A very old sample contains 1 times 10 to the power of 8. What happens to this new sample? It starts to decay. It starts to lose atoms due to the decay. يبقى 8 times 10 to the power of 8, this was the initial amount. After some time, it will decay. After some time, amount of radiation will decay. It will decrease. It will be halved, divided by 2. 4 times 10 to the power of 8. Again, it will be divided by 2. It will be 2 times 10 to the power of 8. Again, divided by 2, which is 1 times 10 to the power of 8. So we have reached the final number, which was 1 times 10 to the power of 8. Initially 8 times 10 to the power of 8, and finally 1 times 10 to the power of 8. How many half-lives happened? 1, 2, 3. So you had 3 half-lives. And the total time, the time of each half-life was 5,700. يبقى 3 times 5,700 gives a total time of 17,100. 17,100 years. Okay, that's it. That's all you need to do. Yes, 3 half-lives. 3 times 5,700 is 17,100 years. Okay, حلو أوي.